Hello, welcome back. This video will cover ACT47 Science section. Okay, let's do it. So when you do science section, we don't read passage, we just straight to the question. Okay, so based on table 1, the number of mice found in given zone increased. The number of larvae per mouse. Okay, table 1, if you look at the table 1, the mouse is decreasing right now, and then per mouse is decrease and increase. So it is no general trend that we can find. So based on figure 1, which organism is essential in maintaining the Lyme disease bacteria in deer tick population. So something that we have to think about is tick egg larva and then adults. Okay. So it says the lymph feeds once on mouse, human, and domestic animals. Okay, so this is the key thing. If you look at here, deer, mice, humans, domestic animals. But then it says specifically deer tick. So tick egg is also feeding once mouse can pick up. That's another thing that we can see. So mouse and mouse, which is mice. Based on table 1, average percent of household inhibited by at least one infected. Okay, so based on table 1, average percent household inhibited by at least one infected person, zone A to E of study was closest to. So at least one. So you can see that, from, I think from here, this is the case. So if you think about A to E average out, it looks like, around this 54 is the average, which is around 50, I guess. So you can calculate that, you add it up and then do the more specific, numbering, but it's going to be around 50, I guess. So 4, suppose additional data had been obtained about total number of infected deer tick in the zone, and then larvae. Given table 1 would predict that the largest total infected deer tick larvae would have been found in which zone. So largest one that we can see so probably in multiplying mice times larvae per mouse, then if it is the largest, that's the biggest number. So it looks like the A is 15,000, which is huge, and then less, everything else is less. So we probably say zone A is the largest. According to figure 2, total number of new cases of Lyme disease was the same for both months in each of the following periods of month, except, so figure 2, new case without this, and new case. So what to see one by one. So September, March and September. March is this much, and September, oh, it's similar. And April and December. April, nothing. December, nothing. Okay. And then May and October. May, October, similar. And then August, November. August, November. No, that's not the same. So obviously D is the answer for this one. Okay, move on. Number 6, if experiment 1 trial had done at 150. So it says that, 100 degree right now, but then it's 150, then how it's going to be. So temperature is going up. Oops. Temperature right now is like around, I'll say around between this one. Okay, so OFC1 has to be between these two, which is around 300, and then between these two, around 2 something. So maybe G is the answer for this one. Experiment 2, for the compound OFC, OFC1 at 180. So which compound? OFC 180 is like 111. So 111, that is something that you can see. And also only information that we can find is induction period per second. Okay, so formula, this is like too huge and small. And CL3 is 148. 9 is too huge too. So, but then compound the fastest decompose. Fastest one is the induction period is the less, that is fastest. That's why this one is the last. So let's see, B is the answer for this one. And then in which following ways that design of experiment 1 different from the experiment 2? Experiment 1 is temperature going up, and then how OFCs. But then experiment 2 is more about same temperature because it says 180 here, and then it just give you each different formula induction period. So temperature, which is H, and the experiment during the period of OFC2 at 100. 100 is 998. So chamber atom So then we have to understand the meaning of the question, the pressure, the relationship between pressure and whatever induction time, and also this is like sort of like in a common sense that I can use, or you can read through, like you have to find the pressure and everything. But then if you think about as pressure build up, as same like 100 degrees Celsius, and then you keep like boiling, and then pressure will build up. That's why it says that here induction period is the pressure rise to 0.20. So it's gonna rise up to 0.20, which is B or D, but it's decreased now. So D is the answer for this one. Certain OFC2 will always break down in the presence of MO more quickly than will OFC. So quickly is 2 has to be the, so it's from like, here, I don't know. So everything is like quicker in a way if you think about it. And then why it's quicker? I don't know, but then like temperature, I mean, all this thing, each temperature, OFC2 is shorter amount of time that they need. So yes, that's J, okay. Information which following is chemical formula for an OFC. Could be, it says could be formula. So something that, we have to think about here, figure 1, that OFC liquid, like, plus MO, they make, this gas, liquid residue. So if you have OFC, then we probably need to have something of these components one by one. And then let's say here CF3, CFO, CF3. So something that, we shouldn't have is CF, COF, CO, and then M is solid. So whatever solid that you have is the one that we're looking for. But then whatever not given is like H2. It's not, and Cl is not, and then H3 is not. So only option that you can choose is A, because that's like CFO and other stuff that you can see. Okay, move on to next passage, number 12, supposed experiment 2. Perform, describe, based on student 2's hypothesis, the percent ovule pollination, the females Zamia cones would be covered with mesh bag would be closest to. So it says activity through wind pollen, which caused 50% pollination event Zamia ovule. Without wind pollination percent, it says without wind, right? And then decreased by 50%. Likewise, without insect pollination, the percent of ovule pollination decreased by 50%. Okay, so it says 50%, so it's H. Student 1 state, while a wind on pollen must blown horizontally to enter these cones, which are how student 2 respond to this. Okay, so student 2 saying that blown horizontally enter these cones. Okay. It says wind tunnel experiments show that the shape of female Zamia cone create air current to facilitate the horizontal movement of this one. So then it has to be female, so either A or B. But then increase, yes, so it's B. Suppose the experiments were performed using natural population Zamia and that all the male cones were covered with a plastic bag. Exclude all this. So plastic bag, that means, it doesn't have, the wind cannot go through. So then either insect or the wind, nothing can go through, right? So because of that, you can see 0. And then student 1 would most likely agree statement Zamia pollen is never not carry long distance by wind. Okay, let me see. Here, wind pollination is infrequent because pollen large and heavy, so it doesn't go far. B. Experiment table, student 1 is the most likely agree. The percent of ovule pollination would be highest. Female Zamia cone that are, so female Because it says this one, wind tunnel, female comes, create air current and doing all this thing. So it's like the wind is really important for this one. So not cover with bag, cover with, yeah, because wind, you shouldn't have anything. Which of following would most likely be used? Control group, experiment one, control group. Which one that you have to cover it up? I mean, like, you know, left it as a control group. Nothing really different. Here, following no other formation. Okay, so male, Samia come cover with a mesh bag. Left uncover, female, Samia cover with a mesh bag. Comes with left uncover. So whatever they try to do here is it says the female Zamia it says the female Zamia cones. That's so we will visit this one, and then absence reveal percent ovulations. Ovule pollination is only 10%. That means that 10% is wind. So then whatever happened that we see, you have to make sure that like, you know, other insects can come in so that they can do pollination. So that's why it's the control. You have to control that you know, nothing like disrupt. Suppose a 3 experiment performed as this question. 2 hypothesis will be best supported. The percent of the population or same with for which of the following 2 groups of female? Covered, 1 covered, 2 covered, 2 covered with a mesh bag, 3 were covered with cylinders. Same thing. So experiment 1, cover it with a plastic bag so no insects can come in, not covered, so it's a completely different idea. And G, 1, cover it with a plastic bag, nothing can go in, and a mesh bag, like only wind can go through, right? So that's why this is different cases, because wind is 50% for this one. And then H, 2 were covered with a mesh bag, which is 50%, and 2 were not covered with mesh bag, which is 100%. So it's not. J, 2 covered with a mesh bag, 50% were covered with cylinders. 3 covered with cylinder, exclude wind, but not insect. No wind. For the mesh bag that exclude insect. So this is same like situation, I guess, because the 50%, like same chance. Like either you cover wind or cover insect. So because of that, J is the answer for this one. And move on to the next one, 19. It was hypothesized soil has highly clay contents where that typical water contents higher than those soil with lower clay contents. Is the hypothesis consist with the result of study 1? So study 1 result, if you think about this one, the question is asking clay contents. Clay is this one right here. And then the typical water content higher than. So water content is 2.9 and clay is 8.5. So if you compare that, it should be yes, because it is high. And then clay, sand, silt, clay is a little bit lower, but still, as clay content through soil increase, the water content decrease. Through soil increase, water contents also increase. I think, yeah, that increase here, and this is also increase this way too, I guess. So it has to be B. And then fourth, so as analyzed as study 1 was found 73 sand, silt 12, water contents 73, 15, 12, 73, 15, 12. Probably like between A and B, because 73 is lower than this and 12, 15 is higher than this, so it's like okay here too, between this two. And then, yeah, so between 2.9 and 6.8 G. Based on study 1, the water contents soil C immediately after being saturated for 24 hours in study 3. Study 3, 24 hours saturated, soil 3. Soil 3 is third, the very last one. And then also it says based on study 1. C. Sand is pretty based on this one. Waters and water contents of soil C. Sand edit, no sand edit. Either or, it's just this or this one, right? Hold on a second. Wind speed based on dry particle contents. It can be this and this as well. So then we have to think about what's wind speed that's given to us. Saturated 24 hours. The simple soil preparing study 2. Tray places shallow water for 20. Simple tray then place the eternal exposed. Tray contains only okay, here too. So wind speed. Study 3, right now, whatever, based on, it says based on study 1, that you have to use the study 3, right? So the soil C is sand is this much and clay is this much and everything is here. So sand is already there. So we have to choose like in this right side of it. And then between like, you know, this 15, like around this, like this one, what to find. I think closest one, 5 and 15. Immediately, it says soil immediately. I think it's greater than 15 because this is like, you know, if it is between these two, then it's between like, you know, 12% and whatever, like, you know, this much high, like, you know, 18%. So the closest one that I can find is B. I guess, yeah, it's kind of tricky. And then the 22, which the following statements threshold wind speed that trial supported by the result of study 2 and 3. Study 2 and 3. Threshold wind speed here. So everything is around like similar. Like, you know, if it is no send, 0.3, send, 0.2. So H, based on result of study 2, for given soil, the additional dried sand moved air produced the threshold wind speed at approximately additional. So you add more, then it's like 0.3 to 0.2, which is, oh yeah, a 1/3 of 0.3 is 0.1, so that's what it is. 0.4, suppose equal volume A and B were collected, thoroughly mixed and oven dried 24 hours and crushed in study 2. At this study 2, added dry sand and threshold wind speed for the sample most likely. Added dries, so it has to be this one, right? And then, so it has to be between these two. So move on to next one. 25. In experiment 1, voltage across the plate increased and capacitance of capacitor decreased as so this one is decreased. Experiment 1 or experiment 1, yeah. So C is probably is decreased, voltage is increased, or plate separation increased. Okay, so D. And then experiment 2, study various following property of the capacitor 2. Voltage decrease, capacitor increase, surface area increase, C increase as well. Surface area, so G. Based on the result of 3 experiments, capacitor with which of the following combination of separation, surface area, highest to 1. So separation, if it is shorter, is better, right? So it has to be between among this ABC and surface area. If it is larger, it's better. So which is this one. So C is the answer for this one. 28, assume K decrease. Material suitability for use between this and based on result of experiment 3, which are following correctly lists this dioxide odor decreasing suitability to use between plate. So experiment 3, K is decreasing to this way. So titanium dioxide is the first one, and then water, and then mica, yes. H. In each trial, experiment 1 through 3, after a capacitor was charged and switch open, which means the current is blowing. What is the charge on plate A? So plate A is this one, and then charge is so it says charge is this one minus this one, but then this is plate B, right? So then plate A means plus 1 times 10 to the A, and then this one cause electrons to glow. Okay, so electron is minus, right? So if you think about it, F, battery flow going like this, minus is going and plate B. Okay, so it's minus, so F is good. And then this is weird. doesn't go like in either direction. S to the either direction. So A is minus. So it's like this. I mean, this is plus, and J also doesn't make sense because it's not flowing. And the next one is 31. It says, according to figure 2 and 3, compound A and B the same so soluble. What temperature? 2 and 3. Soluble compound temperature. Soluble compound B temperature. Same solubility. But then if you look at the number itself as a Y, soluble compound A and then soluble compound B, the scale is way too small. So like basically figure 3 is around like here. They're like going like this. So never met each other. So it's the 32. Solution is made that concentration of 1 mole of compound A, 0.5 mole of compound B. According to the passage, number of moles compound A in solution is. So right now it says compound A is 1 and then compound B is 0.5. Okay. So compound A and compound B. Nothing much. Maximum amount of compound that would dissolve. Okay, so number of molecule in the solution is twice. Yeah, it's like obviously, this is really like an obvious question, I guess. And then chemical claim that compound dissolve exothermical, which means like outside. And water decrease and soluble and increase support data 1, 2, 3. Figure 1, 2, 3. So you lose heat, exothermical. So exothermic is this one. Dissolve as it dissolved, you heat as this endo. So compound B is the one. Compound B, if you look at the table, I mean the figure 3, as temperature going up, it doesn't dissolve. So because exothermic, yeah, and heat is given. So every time it goes, since it is heat is given out, so that less, it dissolves less, I guess. So the 34, edit the compound A, B, water, 25, temperature of solution decrease. So compound decrease, same temperature and solubility is decrease. So which means if it is hotter, will increase more. That's like the A. If it is hotter, decrease more. So then supposed to be compound A is the same temperature, it's not going to dissolve as much, right? So, and then delta H, delta means difference. Difference in heat is positive, yes. That's why heat is same, then it decreases. That's why it's F. Ammonium nitrate is compound that delta H is positive, which means that's compound A. So, and then dissolve 25 based on figure 1. Nitro will transfer heat compound, will absorb less heat from the, yeah, it's A. Because A is 40 something, 59.8. So obviously this 25.7 is less. And then that's what it is. And also it is endo, that's why absolving. Absolve. And then move on to last passage, 36. Says consider planet as travel this orbit with a semi-major axis this, and then extrinsic is this. Based on data figure 2, how many times speed of this one between these two angles? Okay, so figure 2, and then 1.5. So it is so this one we have to look for, and then their eccentricity is 0.1, which is solid line, and then go 130. So 30 is to a line like this one, 1 and twice, so 2 times. Based on data figure 2, how does speed of planet change move perihelion to perihelion while it moves from the planet? So we have to understand these two terms. Perihelion is angle 0 and aphelion is angle 180. So if you think about it, up to 0 to 180, everything decrease and then it increase. So speed decrease and then increase. So speed. And then planet will escape from the solar system if orbital speed is greater than escape velocity. Based on the data figure 2, axis 1.5, which is top one, eccentricity is 0.1, also solid line. Velocity is 44.2, which is each tick mark is 1. So 44 is like here, right here. And then this is the highest it can go. And then if you think about it, you're not gonna like touch at all. So J. Data figure 2, orbital speed of the planet will most likely remain constant if eccentricity planet orbit is. If you see eccentricity is less, then it doesn't move up and down not as much as others. So I guess it is least number that you have to pick. Based on table figure 2, 3.0, eccentricity is 0.5, and then 0. 0.5 it has to be even less, right? And then 3.0 is this one. Less than this one is the one that they're looking for. So it has to be less than 23 F. So that's it for the, excuse me, that's it for the science section of the ACT47. So I'll come back with other sections and other tests as well. So see you again. Bye-bye.